So in this video, we are trying to find the slope of f of x equals x squared at any point x. And then we're going to actually generalize that to find the slope of any function, f of x. So not just x squared. So let's just take a minute and read through this. We just found the slope of f of x equals x squared in a previous video at the specific value x equals 2. We did that by finding the limit of the secant equation, okay, as x approaches 2, and we found that it was 4. So now the challenge is to find the slope at any point x. So what we're going to do this time is we're going to imagine our quadratic, but instead of picking the point x equals 2, we're just going to pick the point x. So this will be x, f of x, or we'll call it x squared. And what we can do is add an arbitrary h value so that we have x plus h as our x value, and then x plus h squared would be our y value. So we're just going to find the slope between those 2 points. So let's do that. It's a difference quotient. So x plus h squared minus x squared all over x plus h minus x. And simplifying this binomial, expanding a binomial will give us x squared plus 2xh plus h squared minus x squared all over x plus h minus x. Well, that's a linear term and that's a linear term, so those will both cancel. So they have h. And then actually the x squared terms will cancel on top, so that I have 2xh plus h squared all over h, right? And then actually that I can factor out an h so that I have 2x plus h over h. The h's can cancel, and basically I just get 2x plus h. And that's going to be a result of the difference quotient. That'll be the slope of the secant line. All right? But that is only for, what is that for? That is only for the equation f of x equals x squared. So now let's continue our talk, and instead of discussing just the function x squared, let's talk about any function. Okay, so let's talk about any function f of x. So if we picked a point on f of x, well, then the result would be x comma f of x. So this point right here, let's say, this point right here would be x comma f of x. And then this one up here might be x plus h comma f of x plus h. So I'm basically plugging in x plus h into the function. All right, and here's your result. There's the slope, the difference quotient, right, and this will be the slope. So f of x plus h minus f of x all over x plus h minus x, and you'll see that the x's cancel out. So this right here, this difference quotient is very, very important, okay, because this is basically the slope formula, right? And what we found out is that if we take the limit of this function, that is going to give us the slope at a given point, at a point. All right, and that is the essence of calculus. So here's the idea. The slope of the tangent line is found by taking the limit as h approaches 0. Now h is a very small value, or as h approaches 0. So h is basically a little nudge in the x direction. So, and that's seen in the first example. This equation actually represents something called the definition of the derivative. and it's called f prime. All right? So let's have a little picture. All right? So let's say I'll draw my x and y axis so that we're comfortable with that, and I have just some kind of curve, and here is my point, x, f of x, and here is my point, x plus h, comma, f of x plus h. So if h is going towards 0, if we're making h go towards 0, then that means that this point gets infinitely close to x comma f of x. All right? And basically what that's going to do is give us the slope of the tangent. I'll try to sketch a tangent line there in this teal kind of color here. All right, so that is going to be an approximate drawing for my tangent line. So anyway, limiting this difference quotient gives us the slope at a point. All right? I think I'll leave the alternative definition for a separate video.